In this video, we are going to perform the static and thermal analysis of composite plate. So we will open the ANSYS workbench. First of all, we will model the composite plate using SAP-PRI. Then we will do the steady state thermal analysis followed by static structural analysis. So at very first, choose the unit. SI system, save the project. Save as, choose the file location where you want to save and this. So yes, thermal and give the name thermal and static analysis of composite plate. Just save as, then drag the ACB pre. So first step will be the engineering data selection followed by geometry modeling and then setup. So we will double click on engineering data. So from here, so we know that composites are made of reinforcement and matrix. So here reinforcement we are choosing as a glass fiber and matrix as a resin epoxy. So we will first of all we will select from here material like composite material. So in composite material we will select the glass and then we will select the resin epoxy. After that we will go to the project. Then next step is to create the geometry. So we can create the geometry using a space clamp or design model. So here we will create the geometry in design model. So open design model. So design modeler, first of all select the unit as we will create the specimen by 30 cross 30 centimeter, or we can keep the unit in meter also. So we just keep in meter. Then we will go to select the XY plane. Then we will adjust the plane from here. We'll go to sketch. From sketch we will select the some rectangle plate and then we will then give the dimension, horizontal dimension, choose this line, this horizontal is like 0.3 centimeter and just enlarge it to go for vertical dimension. This, this, so, so, so. So this is the one plate is created. Now we have to make the surface from this sketch. So go to concept, surface from sketch, select the sketch, apply, and you want just generate. So we have created a surface. This surface having no thickness. Now we will close this window. We will go for modeling. So plate is created. After now we have to define the thickness of the plate. So we are assuming the thickness of plate is 0.5 mm. So 0.5 mm means how much? 0.5 mm. So 0.005 meter. So this is the thickness 0.005 meter. Then we have to do the meshing. For meshing, we will select the entire geometry. We will select the entire surface. Okay, then we will insert the size, and the hairs we are element size we are keeping, like one element will be the 1 centimeter, 0.001, centimeter, and then we will generate the mesh. So each element is created by 1 centimeter cross 1 centimeter, and the thickness of the plate is 0.5 mm. We'll close this window, then we'll go to setup. In setup, these are the steps. First of all is the material data. So material data already selected, e-glass and resin epoxy. Then we have to create the fabric. So right click, create fabric. So we'll choose the material like e-glass as the fabric. Thickness of the each lamina is 0.5. Before that we have to also select the unit. Unit is in meter, or we can select in mm also. So we will go to fabric. This is the e-glass, thickness is the 0.5 mm, and we will apply OK. First fabric is not needed. Then we'll create the element set. Element set is already created for all. Then we'll create the row set. Create row set. Then while using this origin, we'll click somewhere at a point. So here from here we'll get the x, y, z directions. It is fine. OK. Then we'll get to orientation set. We'll create the orientation set. So for creating the orientation set, we have to select the element set. Element set means all elements. Then there should be some point. We will put a cursor on a plate somewhere, so it will define the direction of the layer, in which the direction in which layer is going to be added. So in this direction, z direction, layer is going to be added. From here we will select the row set 1, then OK. After that we'll go to the modeling group. We'll create the modeling. So modeling group 1, so fine. Then we have to create a ply. So in this we are going to create total 4 ply. So first ply is the first orientation set. So first orientation set, ply material will be the fabric 2, whatever we have selected initially. ply angle we are taking 45-degree first ply angle, and okay, then again we are going to create some other ply, create new ply, then orientation set is this, ply material is the 582, then second angling we are going to take minus 45 degree, and the second ply is created, and then we are going to take the symmetry of this. So what we are going to do, we'll just copy, and we will just paste. So we will check the third ply is 45 degree, correct. We'll check the fourth ply is also minus 45 degrees. So 45 plus 45 minus 45 and symmetry. So fine, then we are going to create the solid. So we will get to solid model, create solid models, then from there we will set the element set means all elements. Then drop of material will be the, because e-glass is the fabric, so there will be matrix is the resin materials, global cutter material no need to put, and these are all the as it is, okay, and then from there we will update it. So what we are finally we are going to get the 2 mm thickness of a composite laminate made of a glass fiber and epoxy. If we want to see the direction of the lamina, so we can see this direction. So you can see the, just click over here. So this, just click this, click this. So from here we can see the, from here we can see the direction of the lamina. This is plus 45 degree, this is minus 45 degrees, this is plus 45 degree, this is minus 45 degree. So we will get a 2m. So now we can close it and we can update it. Then we will select the steady state thermal. So just setup file is given to the steady state thermal, so it will automatically take. So we will transfer the solid composite data and then double click. So from here we will define this initial step, like we have to apply the temperature. Just in this case we are assuming this is used in a furnace application. So we are assuming this plate is used in furnace application. One side is the inside of the furnace and other side is the outside of the furnace. So here we will give the like temperature. So we will define it in inlet, in inside wall temperature of the furnace is like we are defining 100 degrees Celsius, or we can, okay, then again we are assuming that outside wall is subjected to convection heat transfer. So we will select this phase and just we are assuming 5 watt per centidegree Celsius is the convection, and the outer temperature is 22 degrees Celsius. Just we are assuming this value can be changed as per our requirements. And then we want what the value we want thermal out temperature variation profile, and whatever we want we can select from there also. Then we will solve this problem. So once we will see this temperature variation around the thickness, so what we can do, just put there, enlarge it, so you can see the temperature variation in thickness direction. So we can see the result by choosing the probe value, 99 degrees Celsius, 99.808, 99 something, 99.4, 99.397. So temperature is varying in the thickness direction in this amount. So from here we can create the temperature variation profile. So in the thickness, that is because thickness are very less. If the thickness is more, it will could uh, vary somewhat in a good amount of range. So now we'll close this window and we can calculate the temperature like heat flux, direction of heat flux, and anything else. So we'll close it. So our main intention in this problem is to find the stress, strain and deformation at under steady state thermal and static structure analysis. So now the next step is choose the static structure. So we'll drag the static structure and just we will put in the solution, or just put it automatically, it will take. So now we will go to setup. Then static structure analysis, we in static structure analysis we are going to define the boundary conditions. So what we'll do, this is the plate. So we'll do define the boundary conditions. Boundary conditions means we'll give the fixed support. Fixed support means we are going to fix all four edges. So we will do this control, we will do this control, do this, and do this. So it is assumed that all four edges are fixed. So now we'll apply a force. So just select the force, and we are assuming that we are going to apply the force of 1000 Newton at the middle of the plate. So we'll choose and just assume we can calculate the middle portion by counting the number of cells. So from here this is 30, from here this is 30. So there will be somewhere point uh, 15 around, it will be the center. Just we are using this is center, and we are defining 1000 Newton force at the middle, and we can change the direction of this. Now it is in upward, so direction of the plate is in upward, correct. So we can, if you want to change the direction, put minus, it will be the downward direction. So correct. So 1000 Newton force is applied over here. So from there now we want to find the deformation, total deformation. From there we want to find the equivalent bound masses stresses. So bound mass, because this is composite made of the lamina, so there will be ply means four lamina, and there is the layer means entire laminate. So first of all we will calculate in the layer. Similarly stress in the layer, we will choose the layer. Now we will choose the strain in the ply. So for choosing the strain in ply, we will go to the imported ply. So there are total four ply. So, so we can choose any ply. So equivalent strain we will just we are taking the third ply. So we will go to this and we'll choose a third ply. We can also select first, second, third all ply. Then we will apply third ply. Similarly, we will go for stress, bound muscle stress, and also in this case also we are choosing third ply. And now we will solve. So now solution is about to done. The solution is done. So this is the total deformation is maximum at the center, equivalent strain, equivalent stress in the laminate. Then we can see the equivalent strain in the second lamina, that is third lamina, equivalent stress in the third lamina. So if from this we can see this animation. because all the edges are fixed. So now coming to the solution, from solution we will read out the solution. We can find the missing information, result, summary, dimensions, number of elements, number of nodes, and everything. Correct. So from solution we can find. So similarly, now we have find out the elastic strain in second ply. Similarly, we can find the elastic strain in first, second, third, fourth. This is the elastic strain in third ply. Similarly, we can find the elastic stress in the first, second, and third ply. Then we can plot the stress variation profile, like similarly strain variation profile, similarly displacement variation profile, and so on. So if we click right, we can insert contact. We click right, we can find out the rename group worksheet result summary. So this is the minimum total deformation is this much, maximum meter, or we can find out this is the result summary. Then we can find out the solve our material, from where we can observe the material properties from available solution data and all. These are the code. This is the code for the, like this code can be used in uh, ANSYS APTL to solve this problem by using programming also. So finally this is done. So we will stop here and